day all of you. In this class I want to continue the analysis of current shunt feedback amplifier. In the last video I completed up to the input and output circuit. Now I'll continue it by drawing the H parameter model equivalent circuit. Okay. Yes, you know the current shunt feedback amplifier consists of two transistors. So you have the terminals like this, B1, E1 and C1, B2, E2 and C2. Okay, now you have to replace the transistors with its approximate H parameter model. So first I'll keep the terminals B1, E1, C1, E2 and C2. Fine. Yes. From B1 to E1, yes, we have HIE. C1 to E1, we have HFE IB. At B1, if you see R dash and RE series combination is there. Yes, R dash and RE. Then you have this RS and the voltage source Vs. Okay. Now at C1, if you see there is RC1. Yes. Then C1 is connected to B2. Yes, it is connected to B2. Again between B2 to emitter 2, we have HIE. Between collector 2 and emitter 2, we have HFE IB. Fine. At the emitter now if you observe, yes, you have two resistors, RE, and in parallel with this, you have another resistor, R dash. Fine. 2 to ground, you have the resistor RC2. Yes, this is your RC2. Okay, so this is your H parameter model equivalent circuit. Now I'll indicate the currents. So this is IB1 and this is IC1. Yes, so next this is IB2 and this is IC2. Let us take it as I0. Yes. So now I'll indicate the resistances Ri and this is, yes, R not exactly at the collector terminal your key. Fine. So here is the total is grounded. Here is a ground. Here is a ground. Total you have one ground. Okay. So now for this H parameter model equivalent circuit, we have to evaluate A, beta, Ri, R0 and then RIF, R0F and AF. Okay. So now, yes, this is current shunt feedback amplifier. We know for the current shunt feedback amplifier, the basic amplifier circuit is current amplifier. Okay. Because output is current sampling, means output is current and it gets mixed with the input in shunt, means input is also current. But for the circuit, they have given Vs and Rs. Now we can change Vs and Rs as Is and Rs by using source transformation. Okay. By the source transformation, yes, yes, we can draw the circuit like this using the source transformation. Okay. So this is your total circuit and here is your, now here is your Ri. Okay. So now let me find all the parameters. I'll start from open loop current gain. The open loop current gain is AI. AI is I0 by Is. I0 by Is can be written as, first you can write I0 as minus IC2. So it is minus IC2 by, yes, you just move this side, just gradually you move this side, IB2 minus IC2 by IB2 into, yes, again IB2 by then IC1, fine. Then you move like this, IC1 by IB1 into IB1 by IS. Yes, this is the way of calculating current gain for a two-stage amplifier. For any two-stage amplifier, this is the procedure. You must start from the back and move towards the front. Okay, so this is the way of finding AI. Now, see here, this IC2 by IB2. What is this IC2 by IB2? It may be IC1 by IB1, IC2 by IB2 or IC by IB. Yes, it is simply HRF. So it is HRF. And this also. See this, IC1 by IB1, that is also HRF. Now you will find only two parameters, IB2 by IC1 and IB1 by IS. So now we'll find IB2 by IC1. Further, you have to consider the circuit from C1 to B2. Fine. Here C1, then it is B2. Yes, between C1 and B2 you have resistor RC1. At B2 you have the resistance RI2. Yes, see it, this is RI2. Fine. Yes, now, yes, from C1 into the circuit, the current is IC1. So the opposite current is minus IC1. This minus IC1 current enters this node and it divides into two parts like this. So now this part is your IB2. So what is IB2? Your IB2 is total current coming to this node is minus IC1 into opposite resistance is RC1 divided by sum of two resistances RC1 plus RI2. Therefore, yes, your IB2 by IC1 is minus RC1 by RC1 plus RI2. Okay, that. Yes, next we must find, yes, IB1 by IS. Yes, now for this you must consider the circuit from IS to B1. Yes, so IS, then take this total equivalent resistance as R, that is equal to RS in parallel with R dash plus RE. Okay, so it is totally your R, and then you have your B1 terminal. Yes, from B1 HIE is connected, all this is connected to ground. So here also IS is coming like this and it enters this node. It gets divided into these two, find these two. So now this current is your IB1. So what is IB1? IB1 is, yes, same way. What is the total current? IS into opposite resistance R by the sum of two resistances R plus HI. So it implies IB1 by IS is equal to R by R plus HI. Fine. So yes, we got this IB2 by IC1 and IB1 by IS. So substitute these two, you will get your AI. So that is your open loop current gain AI. Okay. Then what is the next step? You have to find the feedback factor beta. Now for this you consider only this part circuit. See this? That circuit is enough. So this is E2. From E2 the current is, the total current is IE. IE2, let be IE2, no problem. And through R dash, actually what is our current? Yes, you can verify the previous circuits, it is IF. Total current entering this node is IE2 and the current flowing through R dash in this direction is IF. Okay. So the two currents are in opposite direction. So what is IF again? This IE2 is divided into two parts. One is through RE Yes, another one is through R dash. Okay, but opposite current is IF. Through R dash, the opposite current is IF. So what is IF? So IF is equal to, yes, total current. As the two are in opposite, you take minus into total current IE2 into opposite resistance is RE by the sum of resistance is RE plus R dash. Okay. Yes, now your beta is actually feedback network output is IF and feedback network input is I0. Fine. See this minus IE2? Yes. Minus IE2 is, you can write it as minus IC2. What is minus IC2? Minus IC2 is nothing but your I0. Because IC2 and IE2 are approximately equal. You can write IE2 as IC2. So minus IC2 becomes I0. So what is this IF by I0 now? Simply it is, yes, RE by RE plus R dash. That's all. This is your feedback factor beta. Now what is Ri? See Ri? Ri is this R in parallel with HRE. Yes, what is this R? R is in parallel with R dash plus RE. Okay, then what is R naught? R naught, if you see R naught, here there is no resistance, so R naught is infinite. Okay, then what is AIF? Yes, AIF is, see, AI by 1 plus AI beta. What is this 1 plus AI beta? This is called desensitivity D. Fine. Then RIF. What is this? This is current shunt. With the shunt mixer, input impedance decreases. So RIF is RI by D. Yes, then R naught F. This is current sampling. So as this is current sampling, R naught F is R naught into D. Okay. Yes, then R naught is infinite. So R naught F is also infinite. Okay. So this is about analysis of current shunt feedback amplifier. Thank you very much. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.